Hey everyone, welcome back to The Explainer. So glad you're joining me today because we're jumping straight into something absolutely crucial for network infrastructure. We're going to demystify exactly how network firewalls achieve high availability, HA. And we're not just throwing around theory here. We're pulling all of this directly from the brand new Enterprise Security Operations Guide version 1.0 from February 2026. So whether you're a veteran network engineer or just kind of curious about how massive enterprise networks survive a total crisis, you are definitely in the right place. Let's get into it. Okay, here's a quick roadmap for today's explainer. First, we'll cover why firewalls even need HA. Then we'll look at Cisco FTD's active/standby approach. Third, Palo Alto's session synchronization. Fourth, Fortinet's heartbeats and clustering. And we'll wrap it all up with the ultimate HA comparison. Section 1. Why firewalls need HA. I really want you to think about this high-stakes scenario. What actually happens when your primary firewall just fails? I mean, maybe a power supply blows out, right? Or a firmware upgrade goes totally sideways, or the hardware just outright dies. Well, if you don't have a backup plan perfectly baked into your network architecture, the reality is literally catastrophic. Every single data packet just stops dead. Your remote workers get booted off their VPNs, customer transactions completely drop, and your IT team's phones, they light up like a Christmas tree. The whole enterprise just grinds to an absolute halt. It is, without a doubt, the ultimate nightmare scenario for any IT pro. But hey, that's exactly where high availability swoops in to save the day. HA is essentially our universal cure for downtime. The Operations Guide defines it as a network security architecture allowing for stateful failover and session pickup to maintain continuous operation. Now, the absolute keywords there are stateful and continuous. It doesn't just mean you have a spare box that boots up when the first one dies. No, it means the secondary box already knows every single detail about your active connections. So when failure strikes, your active sessions survive, and your end users, they don't even notice a hiccup.
So, how do we pull this off? Well, vendors usually offer two main setups: active/passive, sometimes called active/standby, and active/active. And getting the difference here is absolutely crucial. In an active/passive setup, you've got one primary firewall doing all the heavy lifting, processing all the traffic. The secondary firewall? It just sits there, quietly syncing data, basically waiting completely idle until something breaks. On the flip side, in an active-active scenario, both firewalls are awake, active, and processing traffic at the exact same time. They share the workload while constantly keeping tabs on each other.
Section 2. Cisco FTD active/standby. So when an engineer gets in to set up Cisco FTD, they have to explicitly link the primary and secondary units. First, you literally configure a high availability pair, telling the system exactly which box is the local unit and which is the peer. But the real magic happens next when you define a state link interface. This is actually a physical cable connecting the two firewalls where they securely whisper their connection states to each other, all locked down by a specific failover key. It's a highly secure, dedicated line of communication. But listen, Cisco FTD has some very strict rules to make this work. The Enterprise Security Operations Guide makes it crystal clear. Both units must have absolutely identical hardware and software versions. You can't just mix and match a Cisco FPR 2110 with an FPR 4145. No way. They literally have to be twins. This strict matching ensures those state tables sync up perfectly for flawless stateful failover. And just as a pro tip, engineers can always verify this sync is healthy by running commands like show failover state or show failover history. Moving on to Section 3, Palo Alto Session Synchronization. Now, when you jump over to set up HA on a Palo Alto appliance, the command line process feels a bit different. The secret sauce here is really configuring the HA1 and HA2 interfaces. By physically separating these interfaces, Palo Alto allows the firewalls to sync control plane data, things like routing changes and config syncs, over one interface, while the heavy data plane information, like active session synchronization, happens over the other one. It's super smart because it guarantees that a heavy traffic spike will never interrupt the firewall's ability to know exactly what its partner is doing. And here's a massive differentiator called out in the Operations Guide. Unlike Cisco FTD, which is all about active/standby, Palo Alto natively supports both active/passive and active/active architectures. Honestly, this gives network engineers tremendous design flexibility. Want a traditional failover setup? You got it. Need an asymmetric routing environment where both firewalls are actively inspecting traffic? You can do that too. And it all relies on that continuous session sync happening over those dedicated HA1 and HA2 links we just talked about. Plus, checking on it is super easy.
Just type Show High Availability State.
All right, Section 4, Fortinet, Heartbeats, and Clustering.
So Fortinet tackles HA a bit differently, using the concept of a cluster. When you look at their setup process, you configure the system HA and set your mode. But the really critical part is setting the HBDEV, or heartbeat devices. This command sets up a continuous heartbeat monitor between your clustered units. It is quite literally the firewalls constantly checking each other for a pulse. Oh, and you absolutely cannot forget to enable session pickup. If you miss that command, sure, the firewall will fail over, but every single one of your active sessions will drop. Enabling session pickup is exactly what guarantees that seamless transition for your end users.
So to recap Fortinet's key takeaways, it's a very robust system. Much like Palo Alto, FortiGate supports both active-passive and active-active modes. It leans heavily on those heartbeat devices for cluster health, and again, you absolutely have to enable session pickup to make the failover seamless. But there's another really cool operational detail here: device priority. By simply adjusting a priority number, say bumping one device up to priority 200, an admin can explicitly dictate which appliance acts as the primary master in the cluster. Basically, highest priority always wins.
Section 5, the ultimate HA comparison.
Okay, let's zoom out for a second and see how these three vendor philosophies stack up side by side. When we look at HA modes, it's pretty clear. Cisco FTD strictly utilizes an active/standby mechanism. It is tried, true, and heavily built around having those identical hardware pairs. However, if your network demands load sharing or some really complex routing scenarios, both Palo Alto and Fortinet step up by offering a choice between active/passive and active/active modes. At the end of the day, the right choice really just comes down to the very specific engineering requirements of your own enterprise.
Which brings us to the crucial point. High availability isn't just some tech configuration you set and forget. It's a major strategic business decision. Whether you lean toward Cisco's strict stateful failover, Palo Alto's dedicated sync links, or Fortinet's heartbeat clusters, you absolutely have to have a plan for when things inevitably break. So I want to leave you with this to ponder. Which of these HA architectures actually best secures your network's future? Think about your hardware budget, your traffic load, and frankly, your team's tolerance for complexity. Really evaluate your own infrastructure needs against these three approaches. Thanks so much for joining me today on this explainer, and until next time, keep those networks resilient.